As mentioned in the email this video is attached to, it is a hot summer day in Louisiana and the grass is overgrown, so you decide to cut it. Your lawnmower has a mass of 35 kilograms and an effective coefficient of static friction with a value of 0.35 with an effective coefficient of kinetic friction of 0.31. If you push down on the mower at an angle of 35 degrees, how hard do you have to push to move the mower at a constant speed? Well, at a constant velocity, the sum of the forces is going to be equal to 0, and that's 0 in the x direction, 0 in the y direction, and also 0 in the z direction, although z is not needed. I drew a force body diagram to illustrate the forces acting on the lawnmower, with the normal force pointing up, the frictional force pointing to the left backwards from where you're moving, mg pointing down, and the applied force is going to be down and to the right. And then from here, all I did was use my formulas here and write the forces that I just said were acting in the direction. So we get the F net x is equal to F cosine of theta minus the frictional force, and again that will be equal to 0. And then for the F net y, we get the normal force minus F sine theta minus mg is equal to 0. And now the friction can be written as and F sub F is equal to mu sub k times n. So F net x is now going to be equal to F cosine of theta minus mu sub k times n is equal to 0, because all I did was exchange the F sub F for mu sub k n. And then this allows me to solve for n using the formula n is equal to F cosine of theta divided by mu k. And then from here, all I did was sub that into F net y to get the equation F cosine of theta divided by mu k minus F sine of theta minus mg is equal to 0. And this allows me to solve for F using the equation F cosine of theta divided by mu k minus sine theta is equal to mg. And then from here, I was able to manipulate the formula to read F is equal to mg divided by cosine of theta minus sine theta divided by mu k. And all I did was plug my values in for that, and I get that it's going to require 165 newtons to push the mower at a constant speed.